solid model called support. Okay, support, and we go here, and then we can turn on the plane. And this one, I'm going to create this on the right side view. Okay, so that will be the right, the top, the front, and the right. So we're gonna do the bracket on the extrude placement define on the right side, and then we say top, and then we have the top. Okay, all right, so we're gonna just do this and turn off the okay, auto display. So we're gonna have the center line placed in here and another center line there, and we can continue with the L shape. Okay, so I will create a rectangle that was from here to maybe somewhere there, and the dimension for the height is 40. Okay, I'm gonna give a dimension of 40, and then the dimension down is about let's see if I go to that, say 5. Okay, 5, perfect. And the depth is also 40, because and then this is 40 by 40, so let's see, 40 by 40. And this thickness, maybe, I think this thickness here is also 5. Okay, so that's better. Okay, what we have here is much better. So then I'm going to create a maybe just delete segment. So I'm going to create a line that goes up to there and then come down here, and then we have up to here. And let me just maybe patch it by going to corner, click on this line and click on that line, so we can patch it. Okay, the corner means, if you just check that, it says trim. When you say corner, means trim entity or cut or extend to other entities. So I wanted to extend this to this entity here. Okay, and that is the total dimension is going to be 40. Okay, so that dimension is 40, and this dimension from top to bottom is also 40. For some reason it's a constraint, so let me see if I give this measurement as 5. We're happy with that, or yeah, that's great. Okay, we have that as so this is if the total is 40 by 40, then I should be able to change that to 40. Let's see what happened. Okay, yeah, it finally it says I will accept that. Okay, so that's acceptable, and everything is good to go, and we have a depth of 40 as well. Okay, so we go to check. So 45, and this is 5, this is 40. I want to make sure that everything is clear now. Okay, check, and we're gonna give a depth of 40 as well. Okay, 40, everything is 40. So okay, so we have a bracket, and nicely done. And if I look at this, is front. Okay, that's a front view, and this is the top view. Okay, that's a top view, which is correct. Okay, no hidden line, that's correct. And then if I look at the right side view, and that's our right side view, perfect. Okay, so I've created this L shape on a plane, a sketching plane called right side plane, and then I made the orientation and references top. Okay, otherwise, if you don't do that, when you create a drawing, you're drawing 3 views that you need to do the to create the layout and blueprint, you will run into some difficulty. You say, why my views are upside down? The reason is because you did not selected the correct sketching plane to begin with for this L-shaped bracket. Okay, all right, great. So then we're going to, so this is, let me change this to shade. Okay, let me see if I can render it and say this is, say, that is the top. Okay, and then we're gonna give it color here. Okay, so that's that two faces there, and then I have a face which is that face, and now we have everything under control. Okay, now we're gonna drill a hole on the top on this here, so we can just use the hole tools. Let's see if I can just quickly drop a hole on that surface, and I'm going to give a 15 by 20. Okay, and that is our front view. Let me just check that. That's the front view. Perfect. So if I go take this handle and then position it along the edge of this model here, let's just rotate them that you see what I'm talking about. So that and then there's another handle that goes from here to this edge. Okay, all right, beautiful. And the diameter is 10. Okay, we're using the hole tool, and this dimension here from the center to there is 20, and from here to the top edge should be 50. Okay, so we locate that hole precisely, and we're gonna use through hole. Okay, through hole, so that's a through hole. We cut the hole through this thickness, and we have from the center of the hole to this edge is 15 units, and from the center to this edge is 20 units. Okay, all right, so I think everything is clear, and we're gonna say check. And then we have two holes we need to create. Maybe I'm gonna use extrude this time, so to show you the extrude also, I'm gonna say extrude placement define. Click on that surface, see that the arrow is pointed along in the direction of the surface, and we're gonna go to a sketch view, and let me just turn off the shade so that you can see the white area. Okay, white area. Okay, so I need to have a reference. Right click references. It doesn't hurt to just put references, okay, in case, and that's good enough. We have a reference here, reference there, solve, close, and I'm going to place two holes in here, and the one here and one here with equal radii, or I'm gonna give a diameter of, or this is a diameter of 5. Okay, diameter of 5, both of them have the same diameter, and then this measurement should be, see that I was almost there, I just eyeballed that, is 15, correct? 15. And I wanted to know the dimension from the center to this, if this is the coordinate or origin of this rectangle or a square, so we go 15 by 10. Okay, by 10. So that's what we have. Next we need to dimension, we're gonna dimension from the center of this hole to the center of this hole, and that will be say it's 20. Okay, 20. Okay, great. So we have 20, we have 10, we have 15, and we know that the entire shape is going to be 40, and it did not like that. Okay, so because it's already, we already given the dimension, so I think it's okay. It's a good idea to just leave them alone. So this is 20, this is 10, this is 15, because we are only worried about positioning two holes using extrude command, and we have it. So let me change this to shading, and we know that I placed two holes on this surface here, okay, of a L shape, of this L shape bracket. Okay, then we say check, and automatically by default is going to extrude upward, but we can click on the arrow, is going to go downward, or we can say all the way through, okay, through. This is the extrude to intersect with all surfaces. Okay, perfect. And we are happy and everything is done, and do not worry about, okay, at this point maybe I need to give a fillet radius, okay, and the fillet radius, there's a mistake in the book. If you go to a student project number 1, it's on page SP-3 at the end of the textbook. There is a fillet radius in this corner here, and that one, it's not given, so I'm gonna make up, okay, I'm gonna make up a size for fillet radius, or we call it round. I'm gonna click on this, see that, I'm gonna click on this line here along that edge, and I'm going to give that as a 6.25 divided by 2, or 3.13, okay, 3.13, and I'm happy with that. And then I'm going to do the same, put a round on this one here, which is 6.25 double. See that? It just the memory, it's in the memory of this beautiful software called Creo Parametric. Is so powerful. I think if you really learn this software, you will enjoy doing the design work, because it's all mathematics, it's all logic, and you don't have to really guess anything. It's just, if you do something wrong, the software is so smart, it's gonna tell you that you don't, it's error, or something is wrong with your work. So it automatically recognized that since I gave the interior fillet or inside fillet half of 6.25, the outside fillet said, oh, you mean 6.25? I said yes, and you helped me out, so we got everything under control. So this is that. So this is half of the exterior fillet, this is interior fillet, and that's it. The reason we put the fillet, when we have a bracket like this, upon impact, if it's a sharp corner, is going to break. In order to improve the strength or stiffness of this, or resistance of this materials to fatigue, and it's going to prevent this materials from failure if this is subjected to cyclic loading. So adding fillet radius is going to improve the fatigue life of this part. Okay, all right. So when you are designing parts for aircrafts, for machines, or any type of if the part is in service for advanced dynamics or rotation or motion, and it's going through law of vibration and just a cyclic, we call it in material science, we call it a cyclic loading, because we have the number of stress amplitude versus number of cycles to failure, and if we don't design our part in a correct way, and it will fail. So we're done.